Okay, so this is a very quick review of the Geometry Week 3 quiz. Parts A and Parts B, I'm using the practice quiz that was originally assigned. We're going to work through all of Part A, making use of relevant reference equations. We'll take a brief pause at B. You should take a brief pause at before B to work through the problems, and then we'll work through B itself. Let's see how this works. Oh, it's working exactly as expected. Alright. This was, again, from Part A's quiz. We're going to take a look at a handful of facts. Let's actually go back briefly. So, let's talk about the relevant information you need to know. For Part A, we needed to know 2, 3, 4 relevant facts. Part A was maybe the harder part. We need to know about tangent lines. Tangent lines are lines that touch a circle only once. Let's try and draw a better circle. So, if I was to have this circle here and have a line coming and touching it here, that would be considered a tangent line. And I could have 2 of these as well. And this is going to be our first sort of relevant fact. If I've got lines that are tangent and meeting at a point, they have the exact same length. This distance from A to, I'm going to call this point B, and from A to C are exactly the same. AB is equal to AC in length. Other relevant stuff we needed to know involving tangent lines is that if you've got a circle, you've got a tangent line touching the circle at just one point, and you've got a line connecting the radius or the diameter to that same point, they're going to be meeting at a right angle. They'll have a right angle right there. So if we'd be able to say we had a right triangle here, would be our situation. And we could then find any angles we wanted. We could find X here, we could find Y here, assuming we had the correct information. We could also use Pythagorean theorem. Remember, if you're talking about the sides, if you're dealing with side lengths here, it's a squared plus b squared equals c squared. You're using Pythagorean theorem. If you're talking about the angles in this triangle, they sum to 180 degrees. The 3 angles that are in this triangle have to add up to make 180. We have a right triangle, so we know one of them will be 90. And also, as we have a right triangle, we would have A and B and C as side lengths on that right triangle, if we needed to find one of those side lengths. The other relevant information we needed to know, that was sort of the tangent line information. Then we had discussion of segments. We'll see those as we get to those problems. Let's go and do a couple problems involving these ideas first. Alright, first problem here. JK and KM are tangent to circle H. Tangent to circle H, meaning right here at J, we have a right angle, so we'll add a right angle. And at M, we have a right angle. We're asked to find what the angle is right here. Well, focus on this fact that I have a 4-sided shape. We have a 4-sided shape. Since it's 4 sides, it's a quadrilateral. All angles will add to make 360 degrees. So let's call this angle H here. We could say 56 plus 90 plus 90 plus angle H equals 360. And it's just subtraction. It's just subtracting from 360. 180, 130. We get angle H would be 124. That would be it. Let's go to the next slide. We got another angle problem here. Let's see, angle, we see HJ, this line HJ is tangent to circle G, meaning it's touching at a right angle right here. It's meeting at one point, touching at a right angle, this line. So I will put a right angle at H. I've got a triangle. We've got J, H, and K making a triangle. Those three angles together have to add up to make 180. So 31 plus 90 plus 2x plus 9 equals 180. Subtract some simple things away. We'll get 2x plus 9. We'll get angle K by itself equals 59. And now just subtract 9, divide by 2. You get x equals 25. X equals 25. That would be it. No real challenges here, no tricks happening in this question. Sometimes they like to trick you, there's no tricks. Here, we're again told that KM and MN are tangent to the circle. But I don't have any angles anymore, I don't have any angle information, so I don't need to worry about it being a 90-degree angle right here. It is, if I draw a radius there, connecting J to N or J to K, it is technically a right angle. But that's not the relevant thing. Remember, what is relevant here is that these two lengths are going to be the same because it's K to M and M to N are two tangent lines meeting at the same point. They're meeting at M. That just tells me that 2x plus 5 equals 3x minus 5. 2x plus 5 equals 3x minus 5. And we'll just combine like terms. We'll get 10 equals x. X equals 10. We got our answer. So it just really showed we added 5, we added 5. And we subtracted 2x from both sides. Those cancel out. Those cancel out. 10 equals x. That property we're going to use a lot more in the next couple problems, but we're not going to have to worry about solving equations. We're going to just have to worry about finding sides. Alright, this question here is asking what is G to H. G to H is not 0.6. F to G is 0.6. We're going to highlight some of these things. F to G is 0.6. And what we need to remember is that from a point outside the circle to a point that is on the circle, that will be the same as long as it's tangent as well. So F to G is 0.6, F to E is 0.6. Those are lengths we'll know. E to D is 0.4, so I to D is 0.4. Going from the circle to a point outside the circle will be the same length as long as the line you're drawing is a tangent line. I to H will be the same as G to H. Those will be the exact same length. They're congruent. So let's make use of those facts. E to D is 0.4, so I to D is also 0.4. If D to I is 0.4 and D to H is 1.4, I to H is just 1. The two lengths have to add up together. 0.4 plus what makes 1.4? 0.4 plus 1 makes 1.4. G to H is 1 as well then. G to H is 1. This isn't the only kind of question they could ask like this. They could also ask you to find the perimeter of the shape now. So you could go and say, if they were to ask you the perimeter, you go, oh, this whole thing here is now 1.6. The whole thing from D to H is 1.4. And F to E, or F to D is 1. Because FD is 0.6. So you'd go 1 plus 1 plus 1.6 gives you a perimeter equals 3.6. You might be asked about perimeter. Same exact idea here, we'll just do it a little bit faster. V to U is 5.3, S to T is 8.6. Going from U to T, T to S should also be the same. Those should be the same length. 8.6. If R to T is 13.8 and S to T is 8.6, R to S has to be the missing distance in between, which is 4.8. If R to S is 4.8, Q to R is 4.8. If X to R is 14.4 and Q to R is 4.8, we just need to subtract them to get X to Q. That'll be 9.6, which means X to W is 9.6 as well. W to X is 9.6. Those were the first 5 questions on the quiz. There are 4 more left, 6, 7, 8, and 9 here on part A. And here's where things get a little bit more difficult and another concept needs to be remembered. We're still talking about segments. We're still talking about segments. So we're talking about the distances of lines. What was relevant to remember here, that is on a reference sheet that I gave you during this test, is this fact. Make sure I've got the right color. We had this phrase that the outside times the whole length equals the outside times the whole length. The outside part of a line times the whole length of the line equals the outside part of a different line times the whole length of the other line. So let's color code that and we'll see it. This outside, we'll use this as from S to T. That will be the outside length there. Looking at the whole length of the line will be R to T. And we'll have to focus and figure out how long that is. Well, if it's 6 here and 12 here, altogether the whole length is 18. So our multiplication problem there, at least on the left-hand side, just looks like 12 times 18. We can do the same thing with the other line. We need the outside part of the other line. The outside part of the other line is U to T. It is 9 long. So the other part is 9. The whole length of the line from V getting my highlighters and colors mixed up, from V all the way to T, we're going to have to add those two lengths together. 2x plus 1 plus 9. That is 2x plus 10. We're going to have to multiply 9 by that value. We're doing the whole length there. Oops. Clicked a question again. Let's go back. We're dealing with the whole length of the line there. So 9 times, and in parentheses, I'm going to write 2x plus 10, because I've got an expression to multiply by instead of just a single number. 12 times 18 is easy enough to do in a calculator. I would expect you to do it in a calculator. 12 times 18 is 216 equals 9 times 2x plus 10. You've got some options. You could get rid of the 9. We're going to just distribute the 9 using sort of a crab claw here. We're going to do 9 times the 2x and 9 times the 10. Get 18x plus 90 equals our 216. And now we'll just combine like terms and solve for x. 18x equals 126. 126 divided by 18 is 7. We're going to get our answer of x equals 7. They might try and trick you. I might try and trick you and ask you what's the length of v to u though. Watch out for that. V to u is 2x plus 1. But since you know what x is, you can just plug it in. You can say it's 2 times 7 plus 1, or 15. Watch out for those tricks. Always make sure that you're answering the question that was asked. We were asked for x. But they could ask you for VU, they could ask you for VT. Let's take a look at another question like that. The important thing to remember is that we have to do outside times the whole equals outside times the whole. Notice our point here was outside of our circle. Here, the same thing is happening. K is outside of the circle. So we're going to do the same process. Outside times the whole equals outside times the total. This does look visually different than the last one, because now we don't have 2 lines passing through the circle. But it is the same idea. Let's start with the outside part of k to j. K to j is entirely outside the circle. So outside part is 5. And the whole length from k to j is also 5. It is possible for the entire part of the line to be outside of the line. So you'll make use of that fact. It is also 5. And we'll just say that to 25 already. Focusing on the other part. Pick a different color. Color orange. The outside part from K to M, K to L is just 2. And the other outside part from, or the total length from K to M, add those two things together. 3x plus 6 plus 2 is a 3x plus 8. We're going to have to multiply those out. We did 2 times 3x plus 8, the whole length outside of the circle. 2 times 3x plus 8. You will have to distribute carefully here. 2 times 3x, 2 times 8. Correct that. We'll get 6x plus 16. equals our 25, and now it's 2 steps to solve. Subtract 16, we'll get 9 equals 6x. We'll get x equals 1.5 in this situation. And luckily, that's all they're asking for. They asked for only what x was. Let's see this again. Or this is question 7. There are 2 more questions, question 8 and question 9. We'll see maybe one more like this. We won't. Alright, the last problem type we have here changes things up. It is no longer outside times the whole. Notice where our lines are crossing. They're crossing inside the circle. G here is inside the circle. This one's actually even easier. The relevant thing you're going to need to know that you would find on your reference sheet is if we label these lengths A, B, C, and D, is that A times B equals C times D. When 2 lines are crossing inside the circle, the segments of one line, the product of the segments of one line equal the product of the segments of the other line. So we can basically set that up here. We've got A here, 5 could be B, 3 could be C, 14 could be D. So we're setting this up as just A times 5 equals 3 times 14. We just do what we can. 3 times 14 is 42. We got 5A equals 42. We divide by 5, we get A equals 8.4. 8.4. We're going to see one more problem like this that's maybe just one step higher in difficulty, but it's the exact same idea. Again, 2 lines are crossing each other inside of the circle. So we can set that up. We can say this part is A, this part on the same line is B, this other part of the line is C, this part is D. I'm actually going to reverse those a little bit. I'm going to say this top one is D, and this bottom one is C. It's just going to be easier. It's going to look nicer algebraically. Doesn't affect your math. All we're doing is A times B equals C times D. So we're saying 8 times x plus 1 equals 4 times 4x minus 7. Distribute it out. Distribute things out. 8x plus 8 equals 16x minus 28. Combine some like terms. We'll get 36 equals 8x. For the value, then x equals 4.5. Watch out for what they ask for. They could ask for R to V. They could ask for R to U. They could ask for things other than x. Always check that you're answering the question that was asked. The most relevant thing you had to do was write down this sort of equation. You had to write down this equation here so that you could then plug in some numbers and solve the resulting equation. I think, alright, that's the end of part 8. Alright, so what you've just seen is all the question types on the Geometry Week 3 quiz, Part A. We're going to take a look at the Part B quiz next. Part B quiz had basically 3 skills as well. The relevant information you needed to know for Part B was the equation of a circle, which we'll see towards the end, and two facts about arcs and angles in a circle that you've seen plenty of times, or that you saw and did practice on. Let's try and draw my best circle today. It's not much better, but that's what we have. What we're going to be seeing is starting with lines meeting outside the circle. What we'll have are arcs here. We have a couple arcs. This arc from these 2 points. We have the arc between these 2 points, and we have this angle here. We're going to give each of those things a name. We're going to call the blue arc here, we're going to call it X. We're going to call the green arc Y, and the yellow will be angle 1. What we're going to have to use on this is this equation here. The measure of angle 1 is just going to be half of the difference of those two arcs, X minus Y. It's always X is always the larger arc. X is always larger. X is always larger. Now, these two lines that I've drawn here that are passing through the circle at 2 points, they don't have to have been passing through the circle at 2 points. They could have been another couple quick pictures here. We could have just had 2 tangent lines here. We could have had just 2 tangent lines, or we could have had 1 line crossing through and 1 line tangent. It would be the same process either way, just to color the things that are relevant. Angle 1 would still be the angle outside of the circle. Y would be the smaller arc, and X will be the larger arc made by the angle. All 3 pictures here are using the exact same equation. It'd be an equation that is on your reference sheet. We'll see some problems like that. The other situation you'll experience, at least involving circles, is another where 2 lines are crossing, again inside the circle. And we'll also label things angle 1, X, and Y. We're going to name this particular angle here angle 1, and we'll label the arcs that are made X, We're going to label the arcs outside them X and Y, and I'll color code those as well. X is blue, Y is green, angle 1 is here. Do note that would also be the same angle 1 over here on the other side. It doesn't really matter which one is X and Y. Doesn't really matter which of those is angle 1 as long as you've got X and Y together on making these sort of vertical angles. The relevant equation that you'd have to use for this one that relates those 3 values looks super similar. It'd be angle 1 equals half of the sum of X and Y, half of the sum of X and Y. When I talked to you about it, we said this angle was in the middle. We said sort of angle 1 is the average of the arcs. Because that's what it is. For our earlier pictures, we said it was different pictures, so we said we knew this had to be subtraction because this was a difference. let's see our just work applied super quickly. We'll say this is x, it's the larger arc. We'll say this is y. The only thing we don't know right here is angle 1. But we know the formula, angle 1 equals half of x minus y, and we just have to plug some numbers in. Half of 75 minus 19. 75 minus 19, 65, 56. Half of 56 is 28. So angle 1 right there, which would be M and O, or L and P, is 28 degrees. See the same thing again. Click, click. All right. Same idea, just in a different situation. All right. I see an angle outside the circle. So I'm talking about angle 1 is outside the circle. It is a different picture than before, so it is half of the difference, x minus y. The further larger thing is x. Inside right here is y. Angle 1 is 28 degrees. We'll plug in the relevant numbers. Half of 65 minus y. Now, I've told you plenty of times when we were doing this that denominators are division. How do you get rid of division? Multiply by 2. So we're going to multiply 28 by 2 to get 56. And we're going to get rid of the 1/2 in the process. We'll get 56 equals 65 minus y. And then a trick I saw one of you do that I really liked, I normally don't think of it this way, but we'll show it, is we subtracted 56 from both sides and got 0 equals 9 minus y. 9 take away what number is 0? 9. 9 take away 9 is 0, meaning y equals 9. So x to v is 9. v to x is 9. Let's see, that was question 11, which would be like maybe the second question on your quiz. Let's take a look at the next one. All right, we got lines meeting inside the circle. This is the middle of things. This is the average of two things. Let's label the larger thing x, the smaller thing y. And we'll label this angle here angle 1. Let's find angle 1 just by going ahead and using our formula. Half of x plus y. Half of 94 plus 62. We just run that through a calculator. Half of 156. That's just 78. Angle 1 is 78 degrees. Let's write that down here. But let's take a minute to read what we're being asked to find. Again, they will try and trick you. I will try and trick you. Answer the question that's being asked. They want NQO. They want the measure of NQO. They want NQO. But that's not the angle I found. I found NQP. Luckily, we need just to remember that these two angles make a straight line. They make 180 degrees. To get NQO, we're just going to do 180 minus 78. If we want the angle up here, we're going to do 180 minus 78. We'll get 102. All right, same idea, a little bit faster. Angle 1 should be half of x plus y. I see 87 here, I'm going to label that x. I see x inside of my problem. Let's just recognize that this is a different x. This x inside of the problem, this x inside of the problem is a different x than here. These are two different x's. We'll call this particular thing here, call it y, call this thing angle 1. And we'll just make our substitutions. 5x equals half of 87 plus x plus 66. We'll get rid of the 1/2 by doubling the other side. We'll get 10x equals 87 plus x plus 66. We'll combine some like terms. We'll get x plus 153